Welcome to the Math Record. Today I'll be covering the first part of the ICTM State 2018 Division AA Junior Senior A Person, which I'll be answering questions 5, 9, and 13. And then the next video I'll answer questions 16 and 17. As usual, scroll down all 20 questions. You want to answer these by yourself, and I'll give all answers to all 20 questions at the end. Let's begin with number 5. Determine the area bounded by the graph 3x squared minus 6x minus 9 and the x-axis. So we have a curve in our axes, so we're gonna have to use something in calculus. So if you don't understand what I'm doing, you're gonna have to understand calculus to do it because I can't really explain calculus. So divide 3 out, that's x squared minus 2x minus 3. And this is x minus x plus 1 and x minus 3. So you have negative 1 and 3. So all I'm doing is graphing for now to see what's happening. So we have a parabola that's concave up, and we have an area that's below the x-axis. So we're going to have a negative area, so then later on we have to change the negative to positive to get our actual area. So what we had to do to get this area, we're going to use something in calculus called integral, and we're going to have to go from negative 1 to 3, because that's what our x-intercept was. So then 3x squared minus 6x minus 9. Okay, and then respect to x, so it's dx. So then so integrate this, which is x to the power 3 minus 3x squared minus 9x. And then we plug in 3 and negative 1. Plug in 3 here, that's 27 minus 27 minus 27. Plug in negative 1 here, so that's negative 1 minus 3 plus 9. So the first number is going to be negative 27. The second number is 5. So negative 27 minus 5 is negative 32. Make it positive, which is 32. And that is your answer for number 5. And that's all you have to do. You just need to understand calculus, and that's like one of the basic integrals. Okay, now let's go to number 9. A is a 3 by 3 matrix such that A to the power 3 is I, where I is the 3 by 3 identity matrix, and A is not equal to I. B is equal to A plus the inverse matrix of A. Determine the value of the determinant of B. Okay, so we have A to the power 3 is equal to our identity matrix, and we have B is equal to A plus A of negative 1. And there's also one more equation that we're going to have to use, and that's going to be A times A to the negative 1 is equal to I. And basically what this is saying is any matrix multiplied by its inverse matrix is the identity matrix, which is true for any matrix that follows the form n by n. So n by n means like it's a 3 by 3, 2 by 2, a 4 by 4, 5 by 5, etc. So basically, an identity matrix is just like 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Or if it's like a 2 by 2, it's like 1, 0, and 0, 1. And the 4 would be, basically there's 0, 0, 0, 1, 0, 0, 0. Basically something like that. But this is a 3 by 3, so we're going to focus on our 3 by 3. So delete this. So what equation do we have to use? Well, if you kind of think it logically, we can't use this equation. This equation we just need to find a value of, so this basically tells us nothing. This is a standard equation, which basically means it's really universal for the for the topic of matrices. So it doesn't really give us anything because it's just a property. So we need something specific. So this equation is specific to this question. So let's use this. So set it equal to 0. So a3 minus I equals 0. And we could treat this as a polynomial. So a minus I times. So to get our a cubed, we gotta multiply by a squared. So a times a squared is a cubed. And this one makes negative I a squared. So we have to have a I times a a. So this and this cancel each other out because we don't have those terms. And then we have this, which is negative I squared times a, which is equal to, so we have to cancel that out. So we need an I squared. So this and this cancel each other out. And then this value, negative I times I squared, that's negative I cubed. So negative I cubed. So this thing will just be I a cubed minus I cubed. And these two are the exact same, even though this is not cubed. And the reason is because an identity matrix multiplied by itself is always equal to its identity matrix. That's just the fundamental idea of having an identity matrix. So basically, even if it's like multiplied by 4 times, 5 times, 6 times, a million times, it's always going to be equal to the identity matrix. And that's going to be equal to 0. So a is not equal to I, so we can't use this equation, so we're going to use this one. So a squared identity matrix multiplied by a matrix is always just going to be that matrix. That's another idea of the identity matrix. And then identity matrix, as I said before, multiplied by itself is just the identity matrix, and that's equal to 0. So what do we have to do here? Well, let's look back to this equation to look what we're looking for. If we think about it, it's really, really hard to find an inverse matrix. So how do we get rid of this? Well, I see this right here. So what we could do is that since both of these are I, we could say a cubed is equal to a of times a of negative 1. Divide a from both sides, so that means a squared is equal to a negative 1. So we can substitute that inside, so that means b is equal to a plus a squared. So what is this? Well, this is right here. So that gives us that b plus I is equal to 0. That means b is equal to the negative identity matrix. And if you want to calculate, if you don't know, the determinant of an identity matrix is 1. So if b is the negative identity matrix, that means the determinant of b is negative 1. And that's your answer for number 9. So you just need to know how matrices work. And basically the fundamental idea of the identity matrix. And now let's go to number 13. 2018 students have 2018 separate lockers in long rows of the school. The lockers are all currently closed. The students line up at the first locker. The first student goes down the rows lockers and opens any locker that's closed and closes any lockers that are open. The second student then goes down the rows of lockers and opens every single second locker that is closed and closes every single second locker that is open. And then the third student goes down the row of lockers, opening or closing every third locker in the same pattern. And they basically just follow the same order. And they're asking for the number of lockers that are open. Okay, so we have 2018 lockers and they're all closed. So if all the students follow that pattern, what's going to be the number of lockers? How many lockers are going to be open? Basically what they're asking. So let's think about this as a small sample. So let's represent doors as numbers, and we're going to say 1, 2, 3, 4, 5, and 6. Okay, so let's just use a small sample. So you could go up to 10. I'm just going to stop at 6 because I'm lazy. But basically, the first locker is only ever affected by the first student. So that means so if it starts at close, it's going to be closed. I mean, it's going to be open because it's going to be affected by the first student because all lockers at the beginning are closed. So the first locker is affected by the first student, so that's going to be open. So the second locker, which is affected by the first and the second student, is going to be closed to open and then open to close. So this is going to be closed. So for the third student, it's going to be affected by the first student and the third student. So it's going to be closed to open and then open to close, like number 2. So it's going to be closed also. Number 4 is going to be affected by the first student, the second student, and the fourth student. So then this is going to be close, open, open, close, and then close, open. So it's going to end at open. The fifth locker is affected by the first student and the fifth student. So this is going to be closed because close, open, and then open, close. And then sixth student is affected by the first student, the sixth student, the second student, and the third student. So that's going to be it's gonna change 4 times, which is basically gonna stay closed. So what does this basically tell us? Well, look at the open uh, uh, lockers, which is really strange because it's only 1 in 4. And why is that though? Because if we think about what the lockers are affected by, it's only affected by the students that are basically by that number of whatever it is. So if you think about it, the first student is only affected by 1. The first locker is affected by 1. The second locker is affected by 1 and 2. The third locker is affected by 1 and 3. The 1 and third student, and the fourth locker is affected by 1, 2, and 4. The fifth is affected by the 1 and the fifth, and the sixth is affected by the 1, 2, 3, and 6 student, right? So why is this special? Because if you think about it, what makes 1? That's just 1. What makes 2? That's 1 times 2. What makes 3? That's 1 times 3. What makes 4? That's 1 times 4 and 2 times 2. And what makes 5? That's 1 times 5. And what makes 6? 1 times 6 and 2 times 3. So what you kind of see is that they kind of come in pairs. So the first student and the fourth student are going to change it from close open and then open to close. So we're looking for a locker that's open. We have to look for a number that's repeated twice because this pair means the second student and the third student cancel each other out. The first student and the sixth student cancel each other out. That means for the only way for them to be open would be if there's a number that's squared. That means only one student is going to change it, but it also still makes that number combination. So what we're going to have to do is that if this is squared, what we're looking for are perfect squares. So all we have to look is perfect squares in 2018. So how many perfect squares are in 2018? Well, if you think about it, all we have to do is any number from 1 squared, 2 squared, 3 squared, 4 squared, all the way up to something squared is less than 2018. So what's that number? Well, 2018, let's just try 10 squared, which is 100, so that's below it. 20 squared is 400, so that's still below it. 30 squared is 900. 40 squared is 1600. 50 squared is 2500. Okay, so that's below. So it's going to be between 40 squared and 50 squared. So let's try something in the middle, like 45 squared. So 45 times 45, so that's 25. That's 20, 20, that's 40, then 2, so that's 42, 16, and then 4, it's 20, 25. So 40 times 45 is 20, 25. So that's a little bit over 2018. So it's probably not going to be 45 squared. It's probably going to be 44 squared. That's the highest it could go. So that means any number from 1 squared to 44 squared, it's going to is going to be the number of student number of locker the number of the locker that's going to be open. So we have 1, 2, 3, 4, 5 all the way to 44. That means there's 44 lockers because it's just 1 to 44 that are the perfect squares. So your answer is 44, and that's your answer for number 13. And as promised, here are all answers for all 20 questions. Well, thanks for watching, and I'll see you at the next math record.